Just by way of demonstrating how clear and simple this method makes working out proportions, we'll use an amoxicillin suspension mix that's going into an 8 milliliter bottle. I'm choosing a pharmacy calculation to start off with because sometimes when you see big words like amoxicillin or chemical compounds being used in a maths problem, it often makes you think from the start that, oh, it's too difficult to do. So just to show you how simple it is, just ignore the big words and look at the numbers. The proportion of the mix is 250 milligrams of amoxicillin to 5 mils of water. But we want to mix up a quantity using 8 mils of water, so what we have to work out is how much amoxicillin powder goes with 8 mils of water. The easiest way to work this out is to just simply cross multiply. Once we write it out with like terms over like, it's the equivalent of two equal fractions, because the ratio of the mix stays the same even though the quantities change. By looking at it as two equal fractions with an unknown on the bottom of one, it means we can cross multiply to bring the unknown to the top of the other side and everything else against it on the other side of the equals. So this is a very simple way of solving for the unknown. And because we know the unknown quantity is going to be in milligrams, we can lose all the signs until we come to the end. It just makes it simpler. To start, we'll bring the unknown to the top of the other side over the equals, and now we'll bring everything over to the other side of the equals against the unknown. Now to finish the calculation, 5 into itself goes once, 5 into 250 goes 50 times, and then 8 by 50 is 400. 400 over 1 is just 400, so the unknown equals 400. So just to look at where we started from, we had a question mark and that answer is 400, as we're looking at both sides as being equal fractions. By dividing the larger fraction on the left hand side down, in this case by 50, you'll see clear why we can assume both sides as equal fractions. Here's what we've done again in fast forward. So, to explain why this method works, let's take a simple bread mix of 100 grams flour to 1000 milliliters of water. 100 to 1000 is the ratio, or 1 to 10 when you break it down. In order to stay true to this recipe, we're going to have to maintain this ratio or proportion, regardless of what quantities we use. If we want to use 40 grams of flour, we're going to have to use 400 mils of water. That's staying with the proportion of 1 to 10. Now, if you look at both sides more closely, you'll see that because we've used the same proportions, this is now the equivalent of two equal fractions. And when both sides start out equal, all we have to do is keep doing the same on both sides to keep the balance. And this is why cross multiplication makes it so easy. In this next calculation, we're going to put the unknown on the top. which will make it even easier. Firstly, we need to write down the proportions of the mix we are dealing with. So it's part A to part B, which in this case is 5 to 100. The amount of part B we need is 805 grams. So we'll write 805 grams in the part B lane over the amount we've written there already. And we don't know the amount of part A, so we're going to make part B equal to a question mark under part A. So, just to recap at this stage, you must keep like terms over like. So part A amounts under part A and part B amounts under part B, or think of them as part A and part B lanes. Now we draw in two lines and squeeze the two equal signs together. This makes it like two equal fractions. We know the answer we're looking for is in grams, so we can lose all the symbols, keeping only the numbers. Now, to get the question mark on its own on one side of the equals, we slide the number that's under the question mark from the divide by position over the equals to the top position on the other side, so it's multiplied by the number that's there already. So 5 by 805 is 4025, and yes, I used a calculator. So to complete, we divide the number on the bottom into divide by position into the number at the top, and that gives us 40.25, and we know that what we're looking for is grams, so it's 40.25 grams of part A equals 805 grams of part B. Next, I want to take a quick look at other areas where we can apply cross multiplication. A fairly common one is speed, and we'll take it that it's kilometers an hour. Taking this statement for simplicity's sake, we'll just change the kilometers into distance and the hour into time, so we're keeping like with like. Kilometer distance, hour time. Now we'll slide time underneath distance and we'll leave speed where it is, so now it is speed equals distance over time. So now you've got an easy way to call to mind the speed equals distance over time formula. Now we'll look at rearranging it for distance and time using the rules of cross multiplication. And the equals there shows that it's in balance, so one side is equal to the other. So now, using the rules of cross multiplication, we're just going to move them around so as everything stays in balance, and we can find what the time and the distance is equal to. So speed is equal to distance divided by time. If we slide the time from the divide by position across the equal sign into the multiply by position, we'll see that speed multiplied by time is equal to distance. So the speed you're travelling at multiplied by the time you travelled for is equals to the distance you travelled. And next, if we slide the speed from the multiply by position across the equal sign to the divide by position down at the bottom, we can see that time is equal to distance divided by speed. So let's see how this works in practice. If a car travelled at 130 kilometers an hour for 3.5 hours, what is the average speed it travelled at? So we're given the distance it travelled and the length of time it travelled for, so we just need to find the speed it travelled. So the speed equals 130 kilometers and the time is 3.5 hours. So it's speed equals distance over time, or the distance divided by the number of hours he travelled for will give us the miles per hour, or the kilometres per hour in this case, which is 37.14 kilometres. So we'll just go back to the start again, and this time we're given the speed, which is 37.14 kilometers per hour, and the length of time he travelled for. So we want to find out the distance. So firstly, let's rearrange the formula so we have the unknown quantity, that is distance, on one side of the equals on its own, and everything else stacked up equal to it on the other side. Speed is equal to distance over time. Slide the time over the equal sign, so we leave the distance on its own, and therefore we have speed multiplied by time equals distance. Now we pop in the values we know, do the calculation, and we see the distance travelled is 130 kilometers. So you'll see we can rearrange or manipulate the formula as long as we keep the whole thing balanced. There are different methods of solving these problems, like in the example here, but I find by laying it out like terms over like, the way we've done already, is a much more straightforward process. So simply write out the information you have. What amount is equal to what amount, keeping like terms over like, and cross multiply this information. We'll back it up for a second and break down what has actually happened here. The divide by 2000 moves across the equals and becomes a multiply by 2000, so it gets multiplied by 1. And on the other side, the x euro in the divide by position moves across the equals to the multiply by, and it's x euro multiplied by 1.36. And now, in order to get the x euro on its own, we move the 1.36 across the equals to the divide by position.